Good afternoon, everybody, and thank you for coming. Thank you to our online visitors as well. This is the Oxford Energy Network webinar. My name is Tina Ford, the network convener, and online we've got Karen, our network coordinator, who's managing the recordings and things behind the scenes. Before I introduce this week's guest, I'm just going to do a preview for next week. So next week, same time, same place. It will be Paul Cross from Oxford University in the sustainability team, and he's going to be talking about heat decarbonisation at the University of Oxford. So lots of big plans at the moment, so we'll get to hear them from somebody who's involved in developing those plans and trying to make it really happen across the university and across the city as well. I'm not actually going to do the full introductions. I'm going to hand over in a second because we're very lucky to have Elisa here, who's an ECM alum, introducing another member of her organisation that she's working with, who's going to talk to us today.
Hi everyone, thank you so much for coming and welcome. Thank you for coming to hydrogen into the UK's energy mix from an industry perspective. So my name is Elisa Gura and I am an ECM graduate. And right after finishing my program, I decided I want to go work in the green hydrogen sector. So I'm really excited to be able to introduce you all to my manager, Becca, who's fabulous and has a ton of experience working in the hydrogen sector. So Becca is the head of project development at Hydrogen Energy, which is a low carbon hydrogen developer. And she's overseeing over 50 megawatts worth of projects that are in development. In addition, she's also the senior project manager for Bradford Low Carbon Hydrogen project, which is the largest hydrogen project to receive government funding or government subsidy. And prior to that, Becca is trained as an electrical engineer, and so she worked on grid connections, electrical design for renewables connections and FLIR. So she has a multifaceted perspective on the energy system from an industry perspective. And I'm really excited to pass it over to her and let her get into the talk.
Hi all, thanks for having me. Yeah, as Lisa said, so kind of aim of today is to go through a little bit about net zero and how kind of hydrogen fits into that. And then also just a deep dive into hydrogen and how we do this kind of in an actual real project perspective, and what, you know, the challenges that we face on that. Cool. Yeah, so as Lisa said, I am probably a little bit unique to the hydrogen industry because I'm a my background. So I started out with everything should be electrified. So worked in distribution network on kind of the grid connection side of things and the assets that we have in the ground currently. And then moved into electrical design engineering. Yeah, at one point was doing gas design and realised I didn't want to farm for gas anymore. So moved into renewables and solar and battery development. So taking my electrical knowledge, I moved into hydrogen. So obviously, a big part of hydrogen is actually how we're going to power it. So that's kind of where my hydrogen journey began about 3 years ago, which in industrial hydrogen, I guess, makes me kind of experienced, which is boring. But that's kind of where my kind of hydrogen experience began. Now managing projects and managing kind of large scale Bradford project, which is progressing quite nicely, and go through a little bit about what that looks like on an actual kind of realistic scale and all the challenges that we face on that. So, as I imagine most of you are aware, we have a lot of net zero targets in the UK. These somewhat change regularly, so I haven't necessarily put exactly the date we're going to achieve them all by, but they kind of rely on the fact that we're trying to hit net zero across the UK, and that relies on us decarbonising the electricity network, our transport sectors and industry. So 3 kind of really big pillars to our carbon emissions currently, and 3 very different challenges, which will have to reach the same goal at the end. So currently in the UK, we use a lot of energy. So we use energy in different ways. Some of the energy we use and we create electricity with it, and we use that power. That comes from various sources. And then we also obviously use oil and gas in their pure form for different purposes. So thankfully, our graphs are getting better. We've started phasing out a lot of the coal. But what you'll also see is that though we're bringing in a lot of renewables, we've brought in a lot of gas. So we phased coal out and we replaced it with gas, which is obviously a lot cleaner, but it's still not clean and it won't be net zero. But we're on a journey to kind of decarbonise all of those streams eventually. So types of hydrogen and how they're made. We get a lot of colours banded around. I think it'll be different by next week over what we call different colours. And you may disagree with some of my colours. There are others, there are more, there are different ones. But the key ones that we tend to talk about is grey hydrogen, green hydrogen, blue hydrogen. Most of the other ones are different iterations of that. You've got gasification of coal, which not particularly green, hence why it's brown. And you've got pink hydrogen, which is really electrolytic hydrogen, but from a different power source. I think there's also yellow hydrogen now, which is from solar. But yeah, so the key ones that I'm really going to talk about is green hydrogen. But just to give you some context about other types of hydrogen. So what is largely produced in the UK at the moment is grey hydrogen. So we make it from steam methane reforming, so taking natural gas and splitting it to make hydrogen and emitting the CO2. The next aim is to move that to blue hydrogen, which is where you do the same process, but you take that CO2 and you sequester it, so you bury it somewhere. But both of the inputs there are natural gas. So as a company at Hydrogen, we don't focus on grey or blue hydrogen. So a lot of this talk is leaning towards green hydrogen, but blue hydrogen has the same level of green credentials, I guess, depending how you want to define them, but it's not something we particularly focus on. So electrolytic hydrogen, I like to describe this as really is like the science experiment that you do in your undergrad or at school, just taking water and putting electricity through it. Even when we get to the industrial scale, it is just a really big version of that in most of what we do. But what you get out of that is hydrogen and oxygen. So they're kind of your main emissions. Largely capture the hydrogen and emit the oxygen, but you can take the oxygen for other purposes as well. So the UK fuel usage and relationship to hydrogen. So as I kind of touched on before, there's 3 key streams of our fuel usage in the UK. So you've got the electricity network. So the electricity network is how we power a lot of things at the moment. It goes through our transmission and our distribution network. And we all probably have the view, and I was going to say that those things that we can electrify, they will go into electricity network and we will power them through renewables. There are some limitations around electricity. I mean, one of the big ones being that you have to use electricity at the exact same time that you produce it. And this is kind of a big key constraint of our electricity network at the moment. So there are a few ways that people are talking about using hydrogen, but a key one being kind of storage of power. And does it allow us to bring more renewables online? But it's not intended that we will take hydrogen and put that.
Sorry, the person who normally does tech support isn't here. The online people can't see the slide, so if you keep speaking, I'm going to be fiddling about with this and trying to fix that.
No problem.
Sorry.
Yeah, so one of the key relevance to hydrogen is that we'll use hydrogen as a storage vessel, replacing things like batteries. Testing myself on the side. Then the other big one is the natural gas system. So we currently transport around 60% of our fuel usage through the gas network, and hydrogen is in itself gas. And there's lots of policies and work going on at the moment about whether we can repurpose our gas network to use hydrogen. It is possible in a lot of areas. There's obviously a lot of work around the physicalities of that and the safety case around it. But hydrogen does have an option to be into the gas network, but also to replace natural gas in industrial feedstocks. So a lot of industries still use gas as their incoming feed. A lot of things that need high heat, high power, they use gas as their main source. The other key pillar is oil. So this is really how we plan our transport. Take that oil and we refine it into many different things, but essentially it comes from oil. And that is largely moved around the UK in pipes, tanks, on the road, on rail, in ships, in planes when it's flying places, and hydrogen that serve as an alternative to these fuels in various different ways and in various different machines. So, as I said before, I come from a very electrical background, so I like to think about electricity as kind of the number one route for a lot of things. But a lot of what I used to do was grid connections. So if you're well up to date in the grid reforms, there's a lot of work going on at the moment about how we connect more renewables into the system, how we get more demand into the system. But this is a major piece of work. I think there was some ridiculous stat that just to connect all of the offshore wind that we wanted to do was trillions of pounds of upgrades in cables. And that is great, but that takes a lot of time, takes a lot of engineers. We have a massive shortage of electrical engineers in the UK, so physically actually doing those upgrades is going to take us a long time. If you apply for a grid connection currently to do any type of renewables, you're probably getting a 2035 connection, and you would consider yourself lucky if you got a 2035 connection. Average probably 2038. I think I saw an offer for 2040 was the pace. So we are 10, 15 years away from even these aren't for large scale offshore wind. This could just be for 50 megawatt solar farm up the road. So we want to convert a lot of things to electricity, but we also have a lot of limitations to that. And in the UK, we are kind of constrained by what we have now and what we can do in the short term and kind of medium to long term to how we get to those targets, because we won't get to those targets just by electrifying everything and just putting more renewables onto the network. So where we lead our hydrogen is to how do we do other things to move some of the industries along while we try and sort out behind us a lot of the other larger scale things. So the UK government is kind of on the same vein, which is always good because government support is often needed to get these things moving. But they've set a target of 5 gigawatts of low carbon hydrogen production by 2030. So they have two targets. One of them is how much electrolytic hydrogen we have on the network, and one of them is how much blue hydrogen we have. So you'll see a lot of large scale blue hydrogen in the industrial clusters, and then they've got other schemes supporting that, and then they've got schemes supporting electrolytic hydrogen. Other policy, so the one thing that has been relatively consistent between the changes of government is that hydrogen has been at the forefront. We are part of the hydrogen allocation round 1, and I think 2 days after Labour got into government, we got a call from Ed Miliband pretty much saying we've read your contracts and we want to push ahead. So thankfully, one of the things that has stayed relatively consistent is that people see hydrogen as being a good vessel for net zero. There's a lot of things to get through on how this works and practicalities. To do 5 gigawatts of hydrogen is going to cost us a lot of money, and we have to work out how we're going to pay for that. Last week, I think they posted a consultation which is about how they levy gas suppliers in order to pay for all of these hydrogen allocation rounds. So that's one of the key things they're working through. The key business model that we work on is called Hydrogen Business Model, which is how they're supporting electrolytic hydrogen. And there's various other funds supporting industry, supporting CapEx financing, people changing their equipment, people buying buses. So there's lots of different pots of money that are around with various different government departments, all kind of leading to this direction. Cool. So a bit of a deeper dive into electrolytic hydrogen and how to actually we use that and what that means in real terms. So I've kind of covered off a few of these, but the key pieces that's especially being pushed by DESNA is about where we use hydrogen. Heavy industries. So we work with a lot of industries that are still using gas. So these are a lot of local British industries that are going to be here for a long time, but they have no alternative. They can't change the boilers. They've either in areas where they can't get power. So a lot of these are relatively remote, or they're just not well connected. If they are down the road from a major housing developer, they now can't get power because it's a limit into what we can do in that area. There's also industries that just need a lot of fire, heat, energy into the system, and they can't move to electricity. So hydrogen is a potential option for them to use it in its pure gas form for their process. There's a lot of work going in about how they use different fuels. So one of the key constraints in moving to hydrogen is that if you can't get your hydrogen and you've moved all the way to hydrogen, then you can't make bricks anymore. Suddenly in a bit of trouble. So at the moment, a lot of industries are working with kind of dual fuel, tri-fuel burners. So it's quite an interesting space about how they manage hydrogen coming in slowly and ramping up to 100%, because most of these things won't go 100% on day one. The other option is for scaling renewables. So as I said, a lot of renewables are 2035, 2040 connections. And we already have a lot of curtailment on our grid. You probably hear a lot about wind curtailment payments and people shutting down when it's really windy or really sunny. So one of the suggestions for hydrogen is that it's a lot easier to store than energy in a battery. So we could use hydrogen directly connected to these curtailed areas or to new renewables to allow us to produce hydrogen where we could put electricity onto the network. Other key one we have is heating. So as I said, there's a lot of work going on around how they put gas into the network and whether we use that directly for heating houses. So there's a lot of discussion between whether we have hydrogen boilers or we move to heat pumps, or what do we do in between. And this is one of the options people are exploring. Another one is heavy transport. So there are a lot of industries that are really key around how much weight they can put on their vehicle or how long they can operate for. And all of these are things that are curtailed by batteries. So there's a fun stat that in the Battersea bus depot, a bus on average spends 7 minutes a day in depot because it comes in and it drives straight back out again, and it does the route all day. And these kind of operations don't really lend themselves very well to spending a long time charging. They don't have the space for people to be stood there. They don't have the infrastructure for it. They just don't have the time. And as much as we'd like to change how we do things, we are also very prone to wanting to keep things exactly the same, but changing to net zero. So a lot of bus depots don't want to buy more buses and sit some of them in depot because that's not what they've ever done. So they don't want to do it anymore. We also work with JCB, who developed a combustion engine. So that's designed to be on construction sites. So for sites where they're lifting large loads around and they're driving around all day, the batteries just don't have enough torque in them to get them moving. And the same with HGVs. If you are driving a HGV, you're probably driving it to its full weight limit. And if you put loads of batteries on it, you can't carry as much load. And if you put less batteries on it, you can't drive as far. So these are the kind of key industries that are a little bit caught in the middle ground, where they can't really electrify, don't have too many alternative options. And this is one where people see hydrogen as being a good option. And then the last one, energy storage, just kind of links to the renewables piece, that it's just it's a vessel to store energy in that you can use later, you can use elsewhere. Hydrogen has a lot of bonuses of the way it's stored. It also has a lot of complications because it is a gas and it is a dangerous gas at times, and you have to store it at quite high pressures, but it is a way to shift without using peak shifting batteries and things. You can do hydrogen storage on a slightly longer term than you could do just kind of pure batteries. So kind of touching on a little bit more detail about how these industries use the hydrogen. There's two key routes for a lot of this. So there's fuel cells, which take the hydrogen, run it through a fuel cell, basically the opposite process to the electrolysis process, and then they get electricity out, and then their emission is water. So currently, the buses on the road that we have that have hydrogen, they use fuel cells. So they have batteries along the bottom of the chassis, but a lot less batteries than if you had a battery bus. And then they run their fuel cell with a tank, and then they keep the fuel cell always is running, and the batteries do their starting and stopping. This is really good for kind of local decarbonisation, because those buses are now just emitting water as they kind of drive down the road. So they're really good for places which are looking at air quality. There are some downsides of fuel cells. So fuel cells are they require quite perfect conditions. So if you were to, for example, put a fuel cell into a digger, and then you get some mud in the fuel cell, they stop working. So they have some really good purposes, but they don't work for all industries. This is kind of a key way that people are moving forward. It obviously doesn't have any other emissions. So with the combustion process, there are still emissions that come in there, though they're not carbon, but fuel cells don't have that. The other key one is combustion. So using it in a lot of the pure senses that gases are used now and fuel is used now. So this can be through a combustion engine, through turbines, or just purely burning it if you just wanted the flame. But they're kind of the two key routes. Combustion is used in areas where they don't want it to be as pure, or they need heat, or they need actually the gas process, as opposed to they want power through the hydrogen. So the key thing that my projects are doing is we're using the hydrogen business model. So this is a scheme by the government. They announced back in 2023 the winners of it. There was 11 projects, and the aim of this was really to kickstart the hydrogen market. So there's a lot of issues with new industries about chicken and the egg. So no one wants to move to hydrogen because there's no hydrogen available, but people don't want to make hydrogen available because they can't make it available unless there's off-takers. So we end up in this loop where we're always waiting for somebody to move. And normally with most new technologies, the government has to be that thing to move. So this was a really good scheme that was put in place. It's probably one of the most competitive schemes across the world. And it basically aims to bring hydrogen down to the gas price. So they were trying to, these are their key targets. They want to push this into areas that couldn't decarbonise otherwise. They wanted it to be a vessel for investment. So if you've got a long-term agreement with the government, it's a lot easier to get investment into it than if you're trying to do it standalone with off-takers. And like I say, to kind of stimulate that supply and demand, build UK infrastructure, and with that comes, energy security, jobs, growth, new renewables, all of these things kind of stimulate the market. And that's kind of the area that they focused on to get that moving. So how the hydrogen business model works. So this is a contract for difference. So what this means is that they will subsidise between the price the customer pays and what it actually costs to produce. So the aim of this whole subsidy was to make it the natural gas price. So this means that if you are a local asphalt burner, you could convert to hydrogen and you would be the same level of competitive in the market because you're paying the same for your fuel. Hydrogen is not able to be made at that price. Even in the most perfect scenario, we will always be more expensive than gas, largely because our gas price is our electricity prices are based on our gas price, and you end up in a bit of a cost spiral. But basically, they've agreed strike prices. So they've agreed it works out to be about £9.50 a kilo, which is how much it will cost us to make hydrogen in the UK market. And then they will pay us a subsidy down to the gas price. And the gas price is what the customer pays. So they'll pay exactly what they would pay a month ahead with gas, but they'll now pay that for hydrogen. So there were some rules around this subsidy to make sure that what we made was actually better for the environment and better for the net zero. So a key part of this is that it must adhere to a low carbon hydrogen standard. So this is a standard that they brought out, which is basically determining what do we define as low carbon hydrogen. So we talk about all the colours of hydrogen, but there's lots, the colours change and what does the colours mean? But this was a standard that basically sets out if you are under this level of CO2 emissions, then your hydrogen is low carbon and you can count it as green for all intents and purposes in that sense. This low carbon hydrogen standard is very complex. It's much more detailed than kind of REGOs, which currently are based annually, and you can buy REGOs and you can somewhat say you're green because all your power came from REGO power. For hydrogen, we have to produce the hydrogen in the same half hour that the energy was produced. This is quite complex, but it does mean that you can be sure that the hydrogen is actually using renewables that are on our grid and at the same time. So it prevents you kind of running in the really peak hours of the day where actually mostly what we're using is gas. It does incentivize people to run in times where there is more solar, more wind on the grid. The standard is set at 20 grams CO2 per megajoule. This means that you couldn't just take grid power. Currently we're at about 33. It fluctuates depending on the weather, but basically you have to be using renewables. But that number does give you a little bit of leeway. So if there, for some reason, there's a period of time where there's no wind, no solar, and you use a bit of gas in the month because you need to keep running, you would still be under the low carbon standard. So all of that's kind of a background to hydrogen and why it's important. And what I do is really kind of using the policies that are in place by people is what does this mean actually for projects? And does this mean we actually get projects away? So I have been on Bradford Low Carbon Hydrogen since it was not a project. I would say this is like my baby of a project because I have been there writing the grant submissions through to getting final sign off from the government, which is very exciting. This was the biggest project in the HAR1 scheme. So we'll be producing 12.5 tonnes per day, 35 megawatts of electrolysis, which is not really a dent in the 5 gigawatt target, but it's a lot of hydrogen to sell. It will be enough to power 800 buses. Context on the UK hydrogen market as it currently stands, total hydrogen used in the UK is 8 tonnes a day. So this project alone, without the other 10 projects, will dwarf what is in the UK usage currently. It is being put quite nicely in a round circle. This is being built on an old gas distribution site. So this used to make town gas way back when they used to bring in the coke and burn it and then fill up the gas holders. So this is what it was used as. And I think 4 years ago, they took down all the holders. They haven't been used in quite a long time since we moved to gas being stored in pipes. But now this is essentially empty ground that was previously used for gas that we're now going to renovate to use for gas again, which is a nice round circle. Comes with it lots of complications because, as you can imagine, old gas sites, there's been a lot on this land, a lot has been done to it over the years. There's a lot of pipes in the ground, but hopefully it will be a new kind of greener industry in Bradford. So this project has been, been going since 2022. We hope to be online by the end of 2027. And this will be hopefully the largest green hydrogen plant when it comes online. So this is what a green hydrogen plant actually looks like, hopefully, when we build it. So this is just give you a bit of context about what goes into a hydrogen plant. So we start with the bare bones, which is the electrolyzer. This is probably one of the simpler pieces of equipment on the site. These are alkaline electrolyzers, so these are lots of metal plates squished together, very, very hard, and then basically producing hydrogen like the science experiment. That produces hydrogen at 30 bar, so that produces hydrogen just above the distribution grid. The transmission grid starts from about 40 bar. But in order to use this in any vehicles, you need to be at 350 bar, or for cars, 700 bar. So a lot of what happens on the site is then compression. So we will end up with 6 compressors to take it to 2 different pressure levels, and a level of hydrogen storage on the site. And we will then take this hydrogen away. So hydrogen is transported currently in tube trailers. So they look quite like diesel tankers, but instead of one big tube, they've got lots of small tubes because they're taking gas at a lot higher pressure. So this site will take 24 tube trailers a day off the site in order to get rid of the hydrogen, to take it to bus depots, HGVs, being used in industrial processes. And then we've also got on-site refueling, so people within Bradford will be able to fuel their vehicles, largely looking at taxi fleets. So there's a big move to Bradford to having taxis on hydrogen. A lot of this is led by, I think you can't get from Bradford to Manchester Airport and back on an EV charge, so they won't buy EVs. Very particular how taxi drivers operate, so that is the main reason they won't change to EVs. And it's, like I say, it's a weird nuance of a lot of industries that they're very particular in the way they do things, so they will only do something if the solution lets them do exactly what they were doing before. So the cost of our hydrogen when we make it for £9.50, we have to pay out a lot of money to build it. So the capex, so the capital cost of building this project, is high. It will be in quite a lot of tens of millions to build a 35 megawatt plant. And that in itself has challenges around getting funding for it, getting investment in what is a very new market. There are some operating costs, obviously, of having to maintain this equipment. Again, that's done by quite specialist people. But the thing that dwarfs everything in hydrogen is the cost of electricity. So you can make whatever savings you want in capex, you could save millions, but if your PPA goes up by £1, your project costs will escalate. This causes a lot of issues around where you put hydrogen plants, how you design hydrogen plants, how do you want to run the plants, because if you can turn down at times when electricity is really expensive, then you can make your hydrogen much cheaper. However, you've also got to play into who are you providing hydrogen for. If you are making hydrogen for buses, you can't just run in the summer because buses run 364 days of the year, and if you don't have hydrogen, Bradford buses don't run, you suddenly are very, very unpopular. So it is a very interesting challenge around balancing all the different elements of a project in order to make the hydrogen as cheap as possible, but also make it reliable, deliverable, and something that people actually want to change to. So challenges of developing hydrogen sites. This, I guess, is the crux of why there are not many hydrogen sites currently around, why they take so long to develop, and what kind of restrict us in the UK. So a big one, and the first one that people tend to think of with hydrogen is the health and safety of it. So I don't know what people's thoughts of hydrogen was before, but when we went to the Bradford consultation event, the first person walked through the door and said, "Is this a hydrogen bomb? Is this going to be," and it's all anyone ever remembers about hydrogen. They don't remember that we used to have hydrogen in our town gas, or that it's a gas that is used in industries currently, and people are using it to make glass, and it's used to make semiconductors. All anyone ever remembers is that. Obviously, hydrogen is an explosive gas. It does have risks to it. It's a very regulated industry in that sense. You have to design hydrogen plants to prevent an incident, but you also have to design them that when there is an incident, it's safe. So you kind of built into your designs that you don't want anything to go wrong, and when something does go wrong, it's safe. So there is probably as many rules about this as there's more rules about this than there are about putting a battery down the road. but it's a really big one for us, and it's a really big one for the hydrogen industry. There are lots of companies developing hydrogen projects, and you're all somewhat in competition with each other in the sense of that you're all competing for the same market. We're all completely in the same field, and if something goes wrong on one project, that will set other projects back. So there is a lot of shared learnings going on around how we manage sites safely, reports of things that have gone wrong, even if they don't lead to a major incident or they don't lead to anything actually happening on the site. Learnings from having these large-scale projects is very much shared within the industry to try and prevent anything ever happening, but also just to make sure that the public is happy with hydrogen and that it's perceived well, and that people are not put at risk and don't feel like they're at risk, because there's as much an issue of people feeling like they're at risk than there is of people actually being at risk, because things can't move forward if people perceive issues. There's a lot of issues at the moment in the battery space with people building grid scale batteries. There's been a few fires, and now all battery planning applications are objected by all communities. So they spend a lot of time and a lot of work having to get through these objections. And all people remember is that there's a fire and it's dangerous. So it's a lot easier to lose a reputation than it is to build a reputation. So it's good to get it right in the first instance and not have to rebuild anything. Another key challenge is the availability of electricity. So as I touched on, electricity is the most key part of the hydrogen market. If you don't have power, you can't make hydrogen. Obviously, this is linked to electrolytic hydrogen, but we have to design our projects with many different moving parts. So if I wanted to build a large-scale hydrogen project that was connected to renewables, connected to wind farms, I would go and build my project in Scotland. If I wanted to connect it to a solar farm, I might go and build it in Cornwall, which is nice and sunny. And if I wanted to do both of them, I'd probably still be in Scotland, because currently I can't build wind in the UK, which is great if I want to just put hydrogen into the gas network, or if I just want to use hydrogen for energy storage. If I want to use my hydrogen to power an asphalt plant, and asphalt has a road life of about 6 hours. So if you can't get your truck of asphalt to your site in 6 hours, you can't use it. So I can't use hydrogen now produced in Scotland, make my asphalt plant there, and then move the asphalt, because the asphalt will have no longer be useful. So either I have to transport my hydrogen, which means I have to put lots of hydrogen into a tank and move it down the roads, or I produce my hydrogen next to my off-taker, but then I can't put it next to my renewables, so I've got to connect to the UK grid. And then I'm going to go through all the challenges of the UK grid, which has all of its constraints and it's curtailed, and I can't get a connection to 2035. So now I'm picking my sites based on the area where there is still some grid left, which is kind of near the off-takes that I want to use, which can connect me in the right kind of time, or you try to build something new and put it where all of these things can be done. So we spend a lot of time balancing between the idealistic position on hydrogen, which is to put it right next to all the renewables and solar and a battery and be pretty much off grid, while trying to match it up with people who are currently using hydrogen or want to use hydrogen, so that I can actually have an offtake for this hydrogen. And then I'm going to skip. The next one is the offtake location. So as I said, there's a cost to transporting hydrogen. So if I get my hydrogen subsidised for £1.50 and it's now the price of gas, if I put it into a trailer, I've already doubled my price of hydrogen. So I'm no longer natural gas price, I am double that. So it's now no longer can be used by a gas customer. It's going to be used by someone who is no longer competing with gas prices, they're competing with diesel prices, which is limiting where you can use that hydrogen. And then the other key feedstock of hydrogen is the availability of water. So we need a lot of power in, a lot of water in. There's a lot of moves to whether water is the next big issue in a lot of countries. I think wasn't it the last line of the Big Short or something, that now we've started shorting the water market. There are places in the UK that have started enacting water policies. This limits where you can build things. I think the whole of East Anglia has some level of water scarcity issues or water restrictions on it. So managing how we build hydrogen plants without diminishing from our water supply, and also not having to necessarily take drinking water, but taking water that we can abstract that doesn't affect the rest of our water supply, is a real challenge as we move through more hydrogen projects. So our first stage projects, this is quite easy. It can be managed from towns' water, but as these projects get bigger and they get more of them, it becomes a more compounding issue. And then the last one, which is probably a challenge to developing a lot of things in the UK, it is government delays. So these projects were announced in October 2023 that they were successful. The first contract was signed in January 2025, and that's before we start actually building out these projects. So these policies are great for stimulating demand in the UK and stimulating investment. But every delay that you get hit with sets back investment, sets back public perception, sets back industry for their faith in this happening. A lot of what we're doing at HyGen is, we need to push ahead of these projects, because we've been talking about hydrogen in an industrial setting for 10, 15 years as being the next big thing. And if we don't get out and do some of these things, it will never be the next big thing, because we'll always be waiting for the next hurdle to get over. I'm hoping that this Bradford will be signed shortly and we will be over those hurdles. But the more policy that we can have consistently, the easier it is for companies to move. Even wider policies around net zero. If you set a standard that you must be decarbonised by 2030, people make a lot of investment decisions around that. If that moves up to 2040, a lot of projects fell away because people just aren't making that capex investment now because they don't need to. If they think it's going to change, even if it's 2030, but they think it's going to change to 2040, they just won't do anything because they're betting that it'll get too late. They won't, they'll change before they change anything. I think that is all my slides. Hope that was somewhat